It's not a vertical circle, it's a horizontal circle. It's just a car going around a level roundabout. What I like about this question though is if you don't know what you're doing, you're flooded with numbers here. You're given a radius, you're given a speed, we'll have to convert that. You're given a coefficient, like you're given so much, you got to figure out what to do with it. It's been a while, so I'm going to go through this again. When a car's on a level curve, gravity's pulling it straight down. The normal reacts and pulls it straight up. There's a force that makes it turn. I typically call it F turn, but the logic step is that at maximum acceleration, the turn force is equal to the friction force. That's the biggest the turning force can be. After that, the car would start to slide. When we set up F net equals ma, F net becomes FF, and the A becomes mv squared over r. On a level roundabout, there's nothing going on vertically, so I would call that a boring case. The normal force is the same as gravity, which of course is m times g. So we get the force of friction is mu mg, and that's equal to mv squared over r. We saw this before, the m's are going to cancel out. We get v squared equals r mu g, or the v squared equals rug equation. What I was saying before, what I like about this is we know the v, we know the r, we know the mu. So if you don't know what you're doing, this is going to rattle you a little bit. 3 different ways to do this question. I'll do it once or twice. The way that I think most people see it is let's calculate the v. How fast could you go around the curve? It's got a radius of 25 and a coefficient of 0.8. So if we plug in an r of 25, a coefficient of 0.8, and then g of 9.8, doing the math on that, I get that the car could go 14 meters per second. That's the maximum that the car can go. With a friction of 0.8, that's as much as friction can handle. In the question, it said the car was going 54 kilometers per hour. Doing the conversion on that, the magic number is 3.6. We've got to divide. That converts to 15. We just did the math to figure out that the fastest the car could go is 14, but the car's actually going 15. The car's going faster than it should be able to go, than it should be going. For that friction and that radius, the car's not going to make it. It'll slide out to a larger radius or something weird will happen, but it's not going to make that curve as it's described. Another way to do it would be, from our v squared equals rug equation, we could say that mu equals v squared over rg. The v squared was given, this time I'll use the given v squared, it was given as 15 meters per second. The r was given as 25, and g is always 9.8. If we calculate that out, we'll get a coefficient of friction of 0.92. This tells us the friction that we need. But we've only got mu equals 0.8. We needed 0.9, we've only got 0.8, we don't have enough friction. The car's not going to make the curve. There is a third way to do this one. Our equation that we're using is that v squared equals rug. We did an equation where I kind of ignored the given speed and calculated how fast the equation predicts it could go. Then I did it a second time where I kind of ignored the given mu, calculated the required mu, and then compared back. A third way would be use our v squared equals rug equation, calculate the radius needed. If the coefficient is 0.8, then the speed is 15. You can, if you're bored, try that one. See what you calculate as a given r, and then compare that back to what's given as the r. And I guess another way you could do it is calculate the 9.8. Ignore 9.8, calculate g. Do we have enough gravity to trigger the friction needed to make that curve? Either way, a question like this, I like the comparison at the end. You've got to think a little bit critically. If you didn't really know what you were doing, this would confuse you because you might just grab an equation and try and jam numbers in. If you don't know what you're doing, in this one, I've given you